All right, so you've just turned in homework 6, and the next assignment is available now on Blackboard. It should be turned in before class next Monday. It includes a couple of bond problems in addition to the stuff that we're going to be addressing starting today. So you could already solve those bond problems. I think the bond problems are maybe problems 4 and 5. I think there's 5 problems total, and bonds are the last 2. And then the other thing that I hope that you've already done is read the entire assignment description for the project and watched the video from a week ago Friday that introduces it. Once you get the spreadsheet set up, then the rest of the project kind of falls into place pretty simply. But another thing you need to do is start thinking about what you want to do for your professional career, a bit of research on how much money you think you're going to make once you graduate. So that could mean talking to graduates or going online and finding data sources related to starting salaries in your field. Because what I ask you to do in the project is kind of put together a cash flow diagram for your life and figure out your income and your spending over the course of your lifetime to see what kind of assets you accumulate and what that means in terms of duration of your retirement, the types of things that you do, and the money that you spend in retirement. So it's a fun project. Ultimately, it's all about planning out your earning potential over the next several decades. But if you try and cram it into the last couple of weeks before November 20th, you're going to really find it much less pleasant and productive than if you begin now. So does anybody have any announcement-related questions before we start talking about external rate of return? Okay, there are analysis means comparing alternatives. So we can't use IRR to perform analysis. Well, sort of we can. We can use it for initial screening, and I suppose that's analysis. We can use it to reject unacceptable alternatives, but external rate of return allows us to compare alternatives. And so it's far more powerful, especially because it avoids one of the assumptions that's built into internal rate of return analysis. All right, so here's a pretty bland painting. I guess we engineers, as a rule, don't generally appreciate art maybe in the same way that some other people do. I mean, I like music, but paintings don't do a lot for me, and this one definitely doesn't do a lot for me, except for the fact that it sold for $450 million. So in 2017, it set the record for the most expensive painting ever sold. It's Salvator Mundi by Leonardo da Vinci, and everybody's heard of Leonardo da Vinci. He's famous for lots of things. I think people allege maybe that he has the first diagram of a helicopter, like he had lots of creative ideas. And so one of the interesting things about this painting is that they're not exactly sure if it was Leonardo da Vinci. Its history as a piece of art is a little bit murky, and part of what makes it murky is that there were other paintings done on top of it that they had to erase and remove in order to get to the original. So there's a whole story about this painting, but one of the shocking things is that the last time it sold before 2017, in 2005, when they weren't quite as sure who painted it and it hadn't yet been restored, then its sales price in 2005 was only $1,175. So imagine that you found something at a garage sale or just kind of a cheap gallery. You bought it for $1,100 and then you sold it 12 years later for $450 million. And somebody's laughing all the way to the bank, right? This is what it looked like when it was purchased in 2005. And if you go online and do a little bit of research about it, they'll show the other paintings that were on top of it and describe how they had to get art restorers to remove all the old enhancements that had been added over the years and try and get it to look more like the original. And now it's not exactly sure even where the painting is. It was purchased by a Saudi Arabian prince, and some people have said that it's on his yacht. Some people have said that it's maybe just in storage in Geneva, but it has not been making the rounds since 2017. They're thinking about trying to build an art gallery in Saudi Arabia, but I think they want to have climate control and security all figured out before they move it there and start showing it to the public. So why do I show you this? It's to make the point that we could not calculate the internal rate of return for this. The person who bought the painting in 2005 and then sold it in 2017, like, you'd think that's a pretty good rate of return, and it definitely is. But the internal rate of return has as an assumption that the money that you're making is being reinvested into another opportunity that yields the same rate of return, or reinvested back into the original opportunity. So a savings account, that's something where you can leave the interest in the account, and then the next month the interest that you earn is based on your principal and all of the accumulated interest to date. So a savings account is an example of something you can do internal rate of return analysis. This, you can't do internal rate of return analysis because you're not taking the profits and reinvesting it into something as profitable as the original. So there has to be some technique where we take into account both the rate at which profits are generated and also where you put the money in the intervening years and what's the rate of return in that secondary account. So just to review from last time, we've talked about the rate of return and how we can use it for initial screening. You can compare a project's internal rate of return against the minimum attractive rate of return and decide whether or not it's acceptable, but you can't compare IRRs and know which project is best. And you also have to be careful because the internal rate of return assumes that cash flows are reinvested into the project or another investment with identical return. So it doesn't work for a lot of things. Actually, if you look at the range of investments that are available in the world, most of them, the internal rate of return is not suitable because you're generating profits and taking the money and putting it someplace else. So external rate of return is kind of the more real-world analysis technique we could use, and it is more complicated because what you're doing is both accounting for the rate at which profits are generated, and then you have to know the external reinvestment rate. So that is when the money is not being reinvested back into the project and you're putting it somewhere else, you have to know what is the rate of return in that other location. So buying a rare painting is one example where you couldn't do internal rate of return. Chick-fil-A, if you think about what the franchisees who open up a Chick-fil-A, they couldn't calculate the internal rate of return on their initial investment. Does anybody know what you have to pay to your initial investment for Chick-fil-A?
It's crazy.
It's crazy low is what it is. It's crazy low. It's very unusual. Chick-fil-A is among the lowest initial investment. The franchisee only has to put in $10,000. Now, less than 1% of the people who apply to be a franchisee are selected. So you only have to pay $10,000 if you are selected, and then the company covers most of the other startup costs. But then when it begins generating profits, they take a really healthy share of the profits from the operator. But still, the operators do pretty well because the average earnings, according to some data that I found, is that the average franchisee for non-mall units, mall units apparently make a little bit less, but $1.2 million a year. So imagine you make a $10,000 investment and then you get $1.2 million per year. I mean, that's a dream. Of course, those franchisees are spending a lot of time. That's not just their profit, it also includes their labor. And I think it takes several years for them to get up to that level. But they can't take that $1.2 million and open a bunch more Chick-fil-A's. In general, Chick-fil-A will only allow one franchisee to have one location. They say from time to time, high-performing franchise operators may be offered an additional business opportunity. So that's the exception. that someone who owns a Chick-fil-A may be allowed to own another one. But in general, they have to take these profits, the $1.2 million per year, and put it somewhere else. So you couldn't calculate an internal rate of return for Chick-fil-A ownership because the overall rate of return has to account the rate that they're generated. And by that, what I mean is you put in 10,000, get out 1.2 million. That's the rate that the profits are generated. But then where does the $1.2 million go during some study period? Like if you wanted to know the rate of return of a Chick-fil-A for a 10-year period, you'd have to know where all of those profits are being reinvested. So maybe they're going into a checking account, maybe the person is investing in bonds or purchasing other equities. So external rate of return has to take the whole picture into account. And that's what we're going to talk about today. External rate of return and how to calculate it. It's probably one of the top 5 most complicated things we'll talk about this semester. So there's, like, I think in terms of what are the topics students seem to struggle with consistently from semester to semester, one is bonds, one is this, external rate of return. There's another one we're going to do later called incremental rate of return that some people struggle with. There's one that is economic service life analysis. So we'll get to the other ones, but like this is not that complicated. There's, you know, maybe 3 moving parts, and if you can keep track of the 3 moving parts, everything will be fine. So I'm glad you're here today because it's much easier for you to learn this when you're in person, I think, than watching the video later. So it allows you to account for the external reinvestment interest rate. So think about the Chick-fil-A owner. When they take that $1.2 million, they have to put it somewhere. The account that they put it at, or the other investment opportunity, that secondary location that the profits go, we need to know what is the interest rate of that other location, and that is I sub I, the external reinvestment rate. So it's the rate that the cash flows can be reinvested. So here's the method. You put together a cash flow diagram of all of your inflows and outflows. And then all of the outflows you discount to the present times 0. And you use the external reinvestment rate as the interest rate that you do the discounting. So find the PV of the outflows. Then next, you find the future value of the inflows. So any of the money that you're receiving during a certain study period, you compound to the end of the cash flow diagram, and you're using this known interest rate. The external reinvestment rate is always a given. That's known, I sub I. Now, what's unknown, the external rate of return, is the interest rate that brings equilibrium between the inflows, which are discounted to the, compounded to the present, and the outflows, which have been discounted to present is the outflows, future is the inflows, and the external reinvestment rate is what you're solving for to find the balance between the two. So this is kind of a graphical representation of it. You're starting off with some cash flow diagram that's got outflows and inflows. You take all of the outflows to the present, all of the inflows to the future, and the interest rate you're using for that is the given external reinvestment rate. And then the, oh, by the way, yes, this is important. If there's an inflow and an outflow in the same year, find the net amount. So what you do is you wouldn't take this little amount to the present. You'd find the difference between the two in that year, and you'd take the net difference between the two. In this case, it looks like the inflows are bigger than the outflows, so you take the inflow to the future. You won't get the right answer if you don't take the net amount. Okay, so then you've got a lump sum that is at the future. You discount it to the present and find out what is the external rate of return, the unknown interest rate, that makes the magnitude of this lump sum amount equal to the magnitude of the outflow when the future value lump sum has been discounted to the present. So it's iterative, because what we're doing is we're trying to find out, playing around with the interest rate over and over again, what interest rate is it that makes this lump sum equal to this lump sum when you've discounted that future amount to the present using the external rate of return. So it seems really complicated maybe at this point, and I guess looking at the formula is not going to make it seem any less complicated, but the procedure, as you see from the spreadsheet and when we start working on it together for the in-class exercise, it's not so bad. It's just a matter of finding the interest rate that makes the present worth of the future revenues equal to the present worth of the expenses. Okay, so think about this. The present worth of the future revenues. So this is times 0. All of these revenues are gathered together in the future, and you compounded them to the future at the external reinvestment rate, and then the external rate of return is the present worth of those future revenues discounted the present, and it's equal to the present worth of the expenses. So the expenses are down, the revenues are up. We're just looking for the absolute value of the two to equal each other. So here's the formula. Expenses will equal revenues. The expenses, which remember that's the outflows, you're finding the present value of all of those and discounting all of those amounts at the external reinvestment rate, which is given. And the thing that is unknown, I prime, is the external reinvestment, the external rate of return. And so the external rate of return is when you're taking all of the expenses and the revenues, combining them together, and then finding the rate which the two are equal. All right, so here's the in-class exercise for Dave. Let me hand out the paper, and I've already told you about the spreadsheet template that's on Blackboard. So if you haven't already, download that file. It's at the bottom of the page on Blackboard. Okay, so we have a cash flow diagram here, and we want to find out the external rate of return. So it looks like, in this example, you have to pay $11,500 now, and then over the course of several years, you're going to have a couple of other outflows. And then there's a series of inflows, and we want to find out the external rate of return. So a couple of warnings. Just because it says 18 years on the cash flow diagram, that doesn't mean that's the study period. The study period is the years in which transactions occur. So it's from times 0 through 13. So don't make the mistake of having 18 being the study period. Then the other thing to remind you of is in a year where there's both inflows and outflows, find the net difference. And so if we look at the structure of this spreadsheet, I've set that up to kind of encourage you to follow the right process. So here's a cash flow diagram. Okay, the handout, does it say what our external reinvestment rate is? 5.5%. So here we'll put 0.055 for the external reinvestment rate. Okay, the end of the cash flow diagram is year 13. So we've got that reverse time column because we're going to be taking the inflows to the future. So we'll need to have this years until year 13 column. So equals 13 minus whatever year we're in. Okay. Then we'll put the net out and the net in for each year. So I'm going to start filling this in. I won't narrate every keystroke, but if you want to look up and see whether you've got the right things in, feel free to glance up and see if you've got the same values as me. So of course, when we do the FB function, that's when we use that reverse time column. So when you do PV, it's just whatever year you're in, because you're moving things back in time to the present. But if you're moving it forward in time to the future, then you want to have how many years it is until that future that we're trying to determine. Okay, so the present worth of the net outflows is $14,835. So by net outflows, what that means is we aren't actually going to have a net outflow for year 5 or year 11 because there are inflows those years that are greater than the outflow. So you need to subtract the two and just have the inflow be less in those years. So there's only 2 years where we have a net outflow. Years 0 and 9. So then the present worth of the net outflows, we're discounting it at the given external reinvestment rate. And so then the sum of it is $14,835. Now, this, by the column says outflow, so I already know it's a negative value. So I'm not bothering to put a minus sign there, because outflow is already telling me that it's an expense. So I don't need to put a minus sign there. Okay, the inflows, same thing with the net. If there's both an inflow and an outflow, then I'm going to subtract the value of the inflow. So look, for example, at year 5, where I've got 4,000 out and 6,500 in. That's why I've only got 2,500 in that year, because the net inflow is the inflow minus the outflow for that year. So the future value is, again, referring to the same interest rate that's known of 0.055. And then here in the function, we need to put the reverse time, how many years is it until the future, into the NPER, skipping over the payment field, and then the amount that you put into the present value is the minus of whatever net inflow there is for that year. So if you take all of the inflows to the future, then it's 95,162. Okay, so this is, if we look back over the procedure here, we've done step 1 and step 2. Step 1 was discount all of the outflows to the present. Step 2, compound all of the inflows to the future. So next, step 3, discounting the inflows. So here's the inflows. The external rate of return requires us to start with some guess. We're going to be doing a goal seek. And so just maybe as a guess, if we put in 1% as a starting point for the external rate of return, what we're going to do is we're going to discount this 95,000. This amount is going to be discounted to the present at the external rate of return until the amount equals the known PV of outflows, which in our case is 14,835.20. So the question is, what interest rate will make it so that $95,000 in year 13 is equal to $14,000 at time 0? So we have to find out what is the interest rate that brings balance between this and that. So equals PV. I'm doing PV at some unknown interest rate, so far unknown, starting off with the guess of 1%. The number of years, so it's in year 13 and we're taking it to year 0. So I'm just going to hard code in here 13 years. Okay, skip over the payment field because it's just a single lump sum that I'm going to be discounting. It's $95,000 in the future. So minus of the amount. Okay, so as it stands right now, when I press enter, it's just going to tell me if you discount $95,000 to year 0 at 1%, then what is the magnitude of that present value? So at 1% discounting, it's 83,000, and that's not what I'm looking for. I'm looking for 14,835. So what about 2%? It's getting closer. 3%, getting closer. 4%, getting closer. Okay, rather than doing it by hand, I can just use the goal seek, and my objective is to set this cell to 14,835.20 by changing the interest rate. All right. So this is the answer. Let me highlight this just to draw attention to the fact that it's the answer. So I'll add some additional annotations here. This is the external rate of return. It is the interest rate that makes the sum of the future value equal to the sum of the outflows at the present. The future value, I guess I could call it the sum of the future value of inflows equal to the sum of the outflows at the present. Okay, so the external rate of return, 15.37%. So this is generating all of these profits over time. But the place where I'm putting those profits only pays 5.5%. So what the external rate of return takes into account is both the quality of your secondary investment and what yield it generates for you. And then also it takes into account the rate at which the profits are being generated. So the external rate of return, one way to think of it is it's a weighted average, because you're generating profits to yourself two different ways. One is with your main investment, and then the other is the external reinvestment account. So if you save this template file, then I think it'll be a useful reference on the homework. But let me give you a warning. You probably don't understand what you've just done. And even if you do, maybe you wouldn't be able to do it another time from scratch. And on the exams, you have to start with a blank workbook. You can't start with the template files that I provide you. So what I challenge you to do is do the same in-class exercise again with the template. So let's make a copy here. I'm going to create a copy, move it to the end here, another try. Okay, so just delete everything that you put in and solve it again with the template, just so you can get those reps in. Solve it another time to help crystallize in your mind what the process is. And then start with just a blank workbook, because that's what you're going to have to do on the exam. And I'd like you to, on your homework assignment, also start with your own workbook. Don't start with my template for the homework assignment. Now, on the exam, you are going to have an equation sheet that you can write little notes to yourself. And so on your formula sheet, you could say maybe what the column titles should be. So that's kind of a way to give yourself reminders on the process, is years until blank, net outflow, net inflow. So you're starting with a blank workbook, but you do have the luxury of a page of notes if you choose to use them. But my point is, I think sometimes in the past why students have struggled is they solve the in-class exercise one time, and then they use the same template file to do the homework, but they never really understood what was happening, why, and they couldn't replicate it on their own. So don't fall into that same trap. My recommendation is do this a couple times, because, you know, it's a little bit abstract until you really have some experience and understand what it's doing. But if you get those reps in, then you'll do just fine on the project, or excuse me, on the exam and the homework. All right, speaking of the project, since we still have some time, let me go back to the slides where I discussed the project, and if anybody has questions, I'd be glad to answer them. So let me see, where did I have those slides? Yeah, one of the things that one of the points I like to make for the project is that when you save money, it's kind of like water coming into a tank. You know, environmental engineering, which is my background, environmental engineering, you can have reactions inside of the tank where, you know, it could be a chemical reaction or a biological reaction, but in finance, the analogy is that you have money coming in to your investments and expenses are drawing down the value of your savings, assuming, like, if the expenses were greater than the income, then the level of liquid in the tank or the level of savings that you have is going down. But there's also a reaction happening inside of the tank, and the reaction is compound interest. So in the project, what I ask you to do is take into account, like, what would be your regular living expenses? What are the extraordinary expenses, like vacations or car purchases or maybe sending children through college, those sorts of things. And track your cumulative savings balance over time to see if you just assume kind of pretty typical rates of return. You know, for example, the U.S. stock market over the long term, I think, has an average return of about 7.8%. So, if you know what your income is because you have an idea of the starting salaries, and in the project I assign you to certain assumptions that have to do with your growth in salary over the years. Let me open up this spreadsheet file that is on Blackboard. So you take your ID number, and if your ID number ends in the number 7, for example, then to set up the spreadsheet, I ask you to analyze certain cases before you personalize it to yourself. Like just to get things set up and understanding the process. You start with, what if the person you're analyzing had a starting savings of $15,000, a starting income of $64,000, the effective tax rate is known. You start off with some given expenses, an amount of charitable donations that this person would be making, how much retirement income they can expect to make from, let's say, Social Security. And then over time, how much their income is growing. So this maybe is that they're getting raises or promotions, cost of living adjustments, and so on. And then I also have every year the living expenses are going up. And then I give you assumptions on what to use as the rate of return on savings. So everybody has a different ID number, but you take the last digit and then there's these series of assumptions. And in the project I ask you to analyze a couple of different cases. And the project has as its idea, there's a philosophy that people should die with no assets. That if you die and have any money left, then it represents a lost opportunity, because what it either means is that you worked for too many years and you could have been retiring and doing other things that were better, or you could have given money away before you died and made an impact earlier and also enjoyed watching the results of your donations, or you could have spent more money. And presumably, there's always something that you can do with your money that brings you satisfaction. So that's the philosophy of the die with zero movement, is either retire earlier, spend more money, or give away more money so that you don't have a bunch of leftover money when you hit the end of your life. So this project is basically asking you to go through a couple of different analyses to look at, first of all, for a hypothetical person, how could they arrange their finances so that they die with nothing at the end of their useful life. So this first case, what would be the investment account balance if the person continues working till age 85? So that's like if they didn't retire at all. They just work until 85 and then maybe that's when they pass away. Then scenario 2 is, what if they retire at 67? Then what would be their savings balance over time if you are applying all of these assumptions about what are their expenses, what are their taxes, how much do they give away for charitable donations each year. And we want to see if they retire at 67, what do their assets look like throughout every year until they hit age 85. So you're going to do like a row by row spreadsheet. And then what age could they stop working and then die with zero at age 85? And so now, instead of just saying retire at age 67, what you're trying to do is see if they make the switch from their working income to their retirement income, then how early could they do that and still make it through their entire life without running out of money? It's kind of interesting how early that happens in some of these scenarios. Some of the scenarios I've given a very low starting salary, and maybe there's a couple of recessions with big decreases in savings. Some of the scenarios have a higher starting salary and fewer of the recessions in the savings rate of return. So all of the backgrounds are a little bit different, but it's interesting to see how early some of them are able to retire. Another way to reach zero assets by the end of the useful life is just to donate more money than the standard assumption. So in the spreadsheet, I'm saying, assume the person is giving away $800 a year. Well, what I'm asking you this scenario for is just increase that until they have maximized the amount of money they could give away and then have zero assets at age 85. And then step 5 is where you personalize it to your own circumstances. And so you put in not just the assumed income and living expenses, but like you try and think about in the city that you plan to live in and your own preferences related to entertainment and travel and the utilities you think you're going to have. Do some independent thinking and research and find out what are going to be your expenses, what do you suppose your starting salary will be, and figure out an optimized way to die with zero assets at age 85, whether that means retiring early, giving away a lot of money while you are in your living years, or whatever the case may be. So the 2 things that you have to submit for the project is a write-up, which includes the answers to the scenarios 1 through 4 and a description of the data sources you used for your scenario 5. And then you also need to submit your annotated spreadsheet file that has all of the calculations. And so that's the Excel file, not just a PDF of it, but the Excel file itself. So I think you should read the entire handout, and if you didn't already, watch the video from Friday of, not just this past Friday, but the one before. And if you do have any questions, let me know. Getting an early start on that, I think, is a really important key to success. So the homework that you've got now, homework 7, you've got 1 week to solve that, and I'll see you in class on Wednesday.